Howdy, howdy, welcome. Thank you for joining us today to talk about a ride wormhole to your infrastructure. So that we're going to be talking today about uh, some things that Dave Randolph has been working on, and he's going to share with you guys. And take it away, Dave.
All right. Thank you very much, Wences. So my name's Dave Randolph. I am an SC at HashiCorp. I have kind of a science nerd background, but as far as infrastructure and code goes, I did start life out as a developer, done a ton of infrastructure in bank IT. Most recently, I was a security and compliance manager for a major industrial automation distributor out of Fort Worth. And now I'm at HashiCorp. So what we're going to talk about today is Boundary, and we're going to look at a little science project that I've cooked up that has actually turned into a really cool demo environment. So without further ado, if I can get my slide to advance. So I am a big fan of physics. Whoops, that went too far. I got a bad lag here. I'm a big fan of physics, like I said, and it's a discipline that takes the world around us and tries to explain it in mathematical terms, right? Things like force equals mass times acceleration, or distance equal 1/2 AT squared. And my favorite, because I tinker around with electronics a lot, is Ohm's law, which is V equals IR. But there's a lot more mysterious thing in the universe that people much smarter than me say that math predicts, and this thing is called an Einstein-Rosen bridge, more commonly known as a wormhole. And the idea is that this connects two places across time and space, and it theoretically allows a traveler to enter one end and pop out the other instantly with no regard for the distance or the time between the two ends. And in popular culture, we have a well-known example of an Einstein-Rosen bridge. All right, if y'all will excuse me for just a minute, I'm going to start closing some browser tabs here because I've got so much lag, I can hardly function in this StreamYard thing. Give me just a second. See if I can't free up some resources. It's got my whole machine bogged down. Okay. Let's try this some more here. All right, so that was going to say, in popular culture, we have an Einstein-Rosen bridge, and that would be the Bifrost, also known as the Rainbow Bridge from Thor. And what it does, it connects the 9 realms and allows the Asgardians rapid passage across space. And this has a lot of advantages, right? It's fast. Infinite space is instantly connected. There's no real concerns about the limitations of that, unpleasant speed of light. And it's secure because nobody can really see you or get to you while you're in the wormhole, and you're more or less impervious to attack. And then finally, not just anyone can get across the Bifrost. We have Heimdall, the gatekeeper, who's controlling who uses it and when. And so when we start looking at the Bifrost, we discover that there's some really good zero trust concepts that come into play. And, zero trust gets thrown around a lot for better or worse. I like to think of zero trust as a set of ideals. Now, there is a NIST document that outlines the 7 pillars of zero trust. But if you think of it as just a set of ideals and principles that you can meet across a wide swath of technologies and processes, you can't really go wrong. I don't know of a single vendor who can come in and sell you zero trust. So if somebody says they can sell it to you for everything, you need to run away because they are not telling you the truth. So let's talk about some of these zero trust principles. The first that I want to talk about is the concept of strong identity. Now, here at HashiCorp, we believe that strong security starts with a strong concept of identity. Heimdall authenticates requests to access the Bifrost and then makes authorization decisions for us. Another principle is to encrypt all your traffic all the time, everywhere. In the Marvel movies, the Bifrost is depicted as a tube bridging the two ends of the wormhole, and you're generally safe when you're inside the tunnel. The third principle I want to talk about is the idea that a user really should have a limited scope of access. Just because they can get to one thing doesn't mean they can get to everything that's on the same network or in space. And the Bifrost enforces this by only allowing passage to the 9 realms. You can't go from Asgard to Vormir using the Bifrost because they're really not connected. You can get close, but you got to walk the rest of the way. And a fourth principle, which the Bifrost doesn't really address as far as I know, is to keep the keys and passwords to your systems a secret, even from the user who's accessing them if possible. The only thing the user needs to know is his own identity and what he's trying to get to. So a real world problem then, and this is where it starts to get interesting, is, well, how do I securely access remote ephemeral infrastructure? I don't really want to open up Secure Shell, Postgres, and whatnot to the public internet. And the other problem I have is that the cloud native tools may or may not allow me to connect to some arbitrary port or protocol for testing, but I still need to get to them. But they're, behind a security group in AWS, and I don't want to open that up. So the good news is that with respect to remote infrastructure access, Boundary can meet these 3 zero trust goals by acting as your own personal Bifrost. That's how I like to think about it. Boundary establishes these authenticated, well-scoped, secure tunnels to remote infrastructure using the ports and protocols of your choice in a way that also can keep that infrastructure password or secure shell key or whatever it is a secret from the user. And it can do all this with very intuitive handling of dynamic infrastructure. And that takes away a lot of the management overhead of maintaining a catalog of ephemeral images. If you think about it, the last thing you want to have to do is go populate your remote access system with information about what hosts may or may not exist from day to day. You want that to just happen automatically. So this workflow that we want to achieve to get to our database goes something like this. Our user has to prove their identity. Okay, so the top of the diagram here, we've got our users, which is the Avengers. Now, we recommend that you prove your identity with some sort of OIDC provider that has a richer context around the larger ecosystem that your users exist in. And then you can have that provider then make risk-based decisions before granting authentication. And I'll give you an example that I was very real to me, I guess, in my last job. And that's the case of I've got a user who normally logs in from Connecticut, and all of a sudden they're logging in from South Korea, right? Or Nigeria. Not to pick on these countries, but they are very far away. And nobody should really be logging in to both of those things without a large gap of time between those login events. And so that's what I mean when we say we can make a risk-based decision about the authentication. Boundary has native usernames and passwords, but you don't get that richer context. So then the next thing Boundary is going to do is it's going to make an authorization decision. And again, in our little Bifrost metaphor here, that's also going to be done by Heimdall. He's going to consult his records and decide whether or not you're really allowed to get on the bridge. And Boundary, by the same token, has a list of ACLs and grants that the administrator specified. And then these are used to actually present a catalog of available hosts and systems to the user. And then finally, the user is going to request a connection to a specific host. In our case, they're going to go to one of the 9 realms. Now, I kind of skipped over access. Along the way, Boundary can either consult Vault for a dynamic credential, or it can use a list of static credentials that it has stored. And then those are used then to give the user access to their final destination there. And then the connection is proxied back to the user in the Boundary case, right? Now, along the way here, in some workflows, the user will never see the password. And in all cases, the remote system may or may not be accessible on the internet. So let's look at our goal now for today. Again, our goal is to ride our virtual Bifrost from my workstation just outside Fort Worth, Texas, to some Postgres database instance or instances running in AWS without requiring those databases to be exposed to the public internet, and without me knowing what those actual credentials are. So that's kind of our zero trust framework that we're trying to solve for. How do we accomplish this workflow? Because if we can do it, it's extremely powerful from a security and a convenience standpoint. All right, so I'm going to kind of get away from the Thor metaphors for a little bit, and we're going to talk about the actual nuts and bolts of what's required to accomplish this workflow. So on one end of the equation, we have our user, right? That's me. And I want to access a target system on the other side of the internet behind some firewall. And so that's my RDS instance. In between all that stuff, we have a few things. We have a control plane, which today we're going to be using HCP Boundary. It's our cloud-hosted SaaS boundary control plane. It really does give you the best experience. It's easy to use. It has a nice GUI. You don't have to run it. And then we have one or more worker systems. And so what is a worker system? Well, a worker system is what actually can proxy your connection. So Boundary, HCP Boundary anyway, comes with 3 built-in public-facing internet workers ready to go. But you can deploy your own as needed. And that's where I might want to deploy one behind a firewall, inside a private VPC, etc. And then Vault then is another component of this. Now it's optional, although it really is highly recommended. And really the best practice is to use Vault, because Vault then can hand out dynamically generated secrets that are required to access the target systems. And if you're not familiar with the concept of the dynamic secret, just to kind of digress for a minute, that's a secret that's basically just in time. It does not exist until you ask Vault for it. And Vault will create that secret. It will hand it off to whoever needs it, but then it has a time to live on it. And when that time to live is up, Vault will destroy that secret. And so if you think about it, okay, Dave, well, I could rotate passwords, right? You could rotate passwords. And I'm not saying rotating passwords is a bad thing. However, a rotated password still exists. A dynamic secret has a finite lifetime. And so once you're done with it, it no longer exists. And a secret that doesn't exist is not a secret that can be used against you. So it has a lot of advantages. Now, not shown in my diagram here is my OIDC provider. And again, this is optional, but highly recommended because of what we talked about earlier with the risk-based contextual decisions around authentications. All right, so now that we understand our goal, which is to connect to a database, and we understand kind of the basic boundary architecture, there's a lot more under the hood, but I'm trying to keep this at a generally high level today. Here's the environment that I have deployed for us today. Now, there are some number of databases. I've only really deployed one because I don't want to run up my AWS bill unnecessarily, but you could deploy however many you want. I have also deployed a private boundary worker inside my AWS VPC. And then I've set up some things in Boundary that are called targets. And so this is something we really need to understand. A target essentially binds 3 things together. It binds an IP address, a port protocol combination, and a credential. And so these are the things we actually need for that worker to connect to our remote host. Our targets today are going to bind Postgres on its normal port to the target database, but the credential then will be created dynamically. So whenever I try to connect to my database, Boundary is going to reach out to Vault, grab a dynamic credential that doesn't have a terribly long time to live, and it's going to make my connection for me. And I have set this up. You can see in my diagram, kind of right down the middle, I got target RDS read only, target RDS 1 read write, target RDS 2 read only. I've actually got two different kinds of credential that Vault will hand out, and I've created two different types of targets. So if I want somebody to have only read-only access, I only grant them access to the read-only targets. Boundary has a very rich built-in RBAC system. And so I've scoped these things. You can see here over on the left, Mr. Read Only and Mr. Read Write are my two users. And they only have access to their respective targets. Okay. And then down at the bottom, we got Vault handing out credentials again. So that is what we are about to look at and how we are going to accomplish this workflow. All right, so we're going to make a connection. Now, I have deployed this entire environment. Every last bit of it has been deployed with Terraform. And let me make this, let me see if I can't zoom this up. And I've forgotten what the zoom command is, so you may have to zoom it on your own screens later on, and I'll have to go dig up that command to zoom. Anyway, here nor there, I deployed this with Terraform, and you can see here are my outputs. Let me see if, can I make these outputs bigger? Let's see here. Nope, I don't know how to do that. Maybe somebody can help me out with that later. So my outputs here, because I wanted this to be friendly to me, actually include the real boundary commands that I use to connect, the real boundary commands that I use to log in. Now we do have a GUI, which is a much nicer experience to log in, but I'm going to do this from the command line because we're just going to kind of go the hard way on this, and so we can really see what's going on under the hood. And then I've got my worker IP EC2. So this is my boundary worker that I deployed out in the field. All right, so the first thing I got to do is I got to authenticate as Mr. Read Only. So let me copy my command. Now, again, I'm going to do this the hard way. I don't have a keyring installed at the moment, so I don't get the benefit of typing in my password here and having it automatically just work. So I'm going to have to set an environment variable with a token after I put in my password. Normal people will not have to do this. I just have a broken keyring right now. So I believe that's my password. No, that's not my password. Let's try it again. There we go. Okay, so I've got to, unfortunately, grab my token. I got to set, just pretend like I'm not doing this part. And so now I should have access to boundaries. So Mr. Read Only can connect. Well, let's first of all, let's see if Mr. Read Only can connect to Mr. Read Write's target. If I've done this correctly, I think I've done it correctly, we will get a permission denied, and that is absolutely the case. So you can see the RBAC in action right off the bat here. So let's get Mr. Read Only. Let me clear this all out. Get my Terraform output back out. What did I actually type? Out. There we go. Give it a second because it's got to go up to Terraform Cloud. Okay, so Mr. Read Only's connection command is this. So I'm going to copy that and paste it out. And with any luck, I will get a Postgres prompt. And I did get a Postgres prompt. Now, if I try to create a table, I have a feeling it will fail. Let's see if it will. Well, I've screwed up my grant somehow. I was able to create my table. I'll have to go look at that and debug it. I swear it was working earlier. I think the matrix glitched on me this afternoon, so I had a little trouble with this. Anyway, in the perfect world, I would have got the RBAC right, it would have created, if for Vault, it would have created an account that did not have create table rights, and it would have not busted my demo in a public stage, but that's fine. I've had worse happen to me. All right, so let's move on then. So the question on the table then is, did we meet our zero trust goals here? Did we do this based solely on my identity and not because that I knew something about the database credentials? We did. We got me connected to that. Did we connect across space and time into a potentially private instance of Postgres? Yes, we did. And again, did I know the credentials? No. And do we think it's encrypted? It is very much encrypted. So we are good to go. Now, this repo, I mentioned that I stood this whole thing up in Terraform. It's part of a larger environment that I built, and it links HCP Packer, it links HCP Vault, it links Terraform Cloud, and now HCP Boundary to show what I felt like was a realistic use case of all these products, because they do all play together, right? They can call each other. Terraform can ask Vault for a credential. Boundary can ask Vault for a credential. Terraform can deploy Boundary. Terraform can consume Packer images. Packer can talk to Vault and get credentials. So I put all this stuff together to experiment with the idea of, okay, what does a golden image workflow look like? And all the way from I'm building an image to I'm accessing the end result of some deployment workflow. So I started with Packer, and I'm just going to talk through this. I don't really have a lot of slides about this part of it, but we will see kind of an interaction diagram in just a minute. But just to talk through it, we start with Packer because I need a boundary worker. And so that's essentially a Linux machine that has the boundary worker binary installed on it. So I need to pre-create an image that has that on it. Or I have to do a lot of work in Terraform that I don't want to do. So I do that, and then I have Terraform consume that image. Now, HCP Packer is, if you're using regular Packer is fantastic, but what you don't get is sort of this next level of tie-in so that Terraform can intelligently consume images from Packer, HCP Packer, and know that, oh, this image is out of date, or I'm not allowed to use this image, things like that. These problems get solved when you move up to the HCP Packer level. So Terraform consumes the image, and then it deploys all kind of stuff. It deploys our database. It deploys, our worker. It has to deploy our boundary stuff. And then it has to configure boundary, and it has to do all this in such a way that it's actually usable at the end. So this was really my workflow goal. And so to show you then that bigger picture, here is the major interaction between 4 HashiCorp products and AWS. Now, I simplified some things. I left off, I didn't go down to the user and the Postgres level, because what I really wanted to show is how the products work together to give us the workflow that we just saw. So at the, and I'll just talk through this again. So, the first thing that happens is Packer's going to build an image, but, I need to do things like set a sane SSH key and set maybe a username and a password. So Packer starts out by going to Vault and saying, hey, I need the secret so that I can stand this, can create this image, right? And then Packer creates the image, pushes it all up to AWS, right? Next thing that happens is Terraform comes along and it says, hey, Packer, I need the image metadata for this worker that I have to deploy. And so Packer makes sure to give it the current one that we've marked as safe for consumption. And it then Terraform goes off and creates our network stuff. It deploys our RDS instances. And then it creates the next thing it does then is Terraform then, logs into Vault. Now we have a new feature with Terraform. We call it dynamic workspace credentials. And Terraform no longer has the long-lived secret to access Vault. So we've cleaned up a nice piece of the zero trust picture there, is that now using OIDC, basically JOT authentication, Terraform logs into Vault automatically, no credentials. And so fetches our boundary worker EC2 SSH key. And remember, that's the same one that Packer got from Vault earlier. Well, now Terraform needs it because it turns out that in order to get a worker stood up, there's some things I have to do that I can't do at image building time. I can only do it after I'm deployed and I have some information from Boundary. So Vault to the rescue, Terraform goes and asks for the key so that it can pull that off. This might be better done by a Jenkins or something, but I don't have that. I'm trying to do this entirely with Hashi products. So we're going to do it this way. So then Terraform goes out, it deploys our worker using the image as specified in the HCP Packer registry. It goes back to Vault. It creates a namespace, some auth secrets, database secrets engines, policies, roles. And then Terraform turns around and configures all the things that it needs in Boundary, right? And then finally, the last piece of this is when I say, hey, Boundary, I want to connect to a target, it goes to Vault, it asks for a dynamic credential, and it proxies that credential in the connection over to the AWS RDS instance, as we saw earlier. And you can see again, just to drive it home, at no point, let's leave out of here. I'll clear it. We'll do this one more time. Hopefully you guys can see this, but all I did was say, hey, Boundary, connect to Postgres. Here's my target ID. Here's my database name. And Boundary took care of the rest of it. Using SSL, we got TLS 1.2. That looks pretty good. And I never saw the password. I'm into my infrastructure. I've traversed my virtual Bifrost. Now, I'm going to put up the Q&A slide. We don't have at the moment, or I don't know how to do a Q&A while we're live here. Whoops, that went too far. Still got the lag. But I'm going to go pop over onto our Discord channel, which if you're here, you've probably gotten here through the meetup link, and it should have the Discord channel link in there. And I will be over in the Discord to answer questions. So with that, I thank you very much, and I'll see you over there.